Dear participants, please pay attention as this is a live event. So it's not required at your end that you have to mute yourself. By default, it has a setting that no one will disturb you and the event is a kind of broadcast. So from our end, you will get all the things. And very important thing we want to tell you for the doubts and the questions you have, you just drop your questions in the question box is there. You drop your questions. At the end of the session, after 1 hour, we will address your all the questions after once the session has been done. In between, we don't allow that. Anytime you can drop your questions, no issues. After the session, the resource person will address each of your questions. Thank you.
A very good morning and a warm welcome to everyone joining for this live knowledge sharing event on machine vision organized by IEEE Student Branch Presidency University in association with IEEE Bangalore section and Department of Computer Science and Engineering Presidency University. It's an international webinar and today we welcome you all. Thank you for joining us for this webinar. My name is Shaleen Bhatnagar, and I'm Assistant Professor in Department of Computer Science and Engineering, and I will be your host for today's event. Now, I would like to request Ms. Mitali Haldar, Assistant Professor, Department of CSE, Presidency University, to address the gathering. Mitali ma'am.
Thank you so much, Shalini ma'am. With the mantra Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwara, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. With the blessing of God Almighty, I'm so joyous to present and welcome you all on the Teachers' Day, and I'm so happy that you all joined this great event for international this live knowledge sharing event. I am Assistant Professor Mitali Haldar from the Department of Computer Science Engineering. On the behalf of Department of CSE, I welcome Chancellor Honorable Nisar Ahmed Sir, Dr. Radha Ma'am, Honorable Vice Chancellor, Indira, Dr. Surendra Sir, COE, and Pro Vice Chancellor, Associate Dean Kalai Rasan Sir, Department Head Dr. KG Mohan, our IEEE mentor, Dr. Divakaran sir, all the faculty fraternity, all the participants, all the loving students, and the most special, our resource person, Mr. Ashish Tiwari. Before proceeding, I just want you all to introduce with our resource person and about his credentials. As many of you already know about Silicon Valley, California, in the United States, that serves as a global center for high technology and innovation, not limited to autonomous car startups, machine learning, AI, robotics, etc. Today, we are so happy to have Mr. Ashish Tiwari, one Silicon Valley robotics engineers among us as a speaker. Mr. Tiwari is a senior software engineer and architect in Robotics R&D, ABB Incorporation, which is a pioneering technology leader in robotics, power-heavy electrical equipment, and automation areas. Mr. Tiwari owns research interest in machine vision, in robotics. Mr. Tiwari works are based in 3D vision, data segmentation, 2D and 3D object recognition, applying 3D point cloud-based machine learning techniques, automated extrinsic calibration of depth sensors, online calibration of depth sensors. He and his team are trying to solve complex research problems in robotics using machine vision. After finishing engineering and master's from Premier Institute in India, Mr. Tiwari also had a master degree from United States Research University and has been part of research labs. Mr. Tiwari will be speaking with us today about machine vision in robotics. So before, without much delaying, I like to request to Mr. Tiwari to come and share his valuable knowledge with all our participants. Mr. Ashish Tiwari, please welcome.
Yeah, hi. Good morning, everyone. Thank you, Mitali, for introduction. And first of all, happy Teachers' Day to everyone. You guys able to see my screen, right?
Yes, sir.
Okay. So basically, yeah, thanks for introduction. And basically, if people are joining from India, it's very good morning, or if some from other country, like good morning to them as well. Maybe we can say all the time is good morning. So my name is Ashish Tiwari, and as Mitali have already told you guys, I work here as a senior software and architect into the robotics industry. And basically, we are trying to use machine vision in robotics and trying to solve some different complex problems. So ABB also work in robotics, one of the segment, and we have basically we are into the industrial robotics segment. And there are different application in industrial robotics like car painting and their warehouse automation and all. There we need this machine vision. So me and my team, we are working in this area. And today I would like to give more brief about this machine vision in robotics area. And I have been told most of our audience are students like third year or final year. So I have prepared basically like introduction about the machine vision, and some are professionals. They are also welcome. They might find some repetitive, but just please bear with me. And if any question, you guys can, yeah, you can put in a questionnaires, and we would happy to answer those queries. Yeah. So so I'm gonna start. So basically, our topic is machine vision in robotics. So now the agenda for the today presentation is like I would like to divide in different sections. So basically, we're gonna cover what is machine vision, then major uses of vision system in robotics. Then we're gonna see why we should use a machine vision. Then in general, there are vision system applications. Then we can find out what are the elements of the vision system. That could be image formation. Then if we go in a robotics area, so there are coordinates transformation in robotics. Then there are we also try to segment in machine vision in 2D machine vision, 3D machine vision, and there are some important and good resource and some vision tools for students or newcomers, those who would like to have career in machine vision or computer vision, and then computer vision as a service. And there are some research problems. So this would be the agenda. So I'm gonna start about the introduction, right? So basic introduction about the machine vision and robotics. And first of all, what is the machine vision? So if any one of you are listening, so basic motivation comes for the machine visions from the human. So what is actually researchers are trying to do, right? Researchers are trying to do to make a robot or enable the computer to do things like uh, robot is can able to do whatever the human can do. Now human have different capabilities, right? So we have a senses, we can hear, we can taste, right? And then we have a vision. So we have a eye, we can see things, and then we can decide. So now human has the eye. The similar manner, now robot or computer would like to see things and would like to decide, would like to take some decisions. So basically, one sense of the human is just a one sense, that the eye, the vision. So similarly, the ability of robot or computer to see, that we can say that's the computer vision or machine vision. So now we can say another sense, if we go in a robotic context, so robot is just machine vision is just like a sensor that using that robot can see, and using those some computers, some algorithms we can process. If there are different applications, if industrial robot, we can have different application like inspection or okay. So machine vision is also, if you see the left hand side, so I have taken this graph from Wiki just for introduction. This is basically computer vision, And the basics of computer vision also is image processing. So it's also called machine vision, image processing. There are different signal processing. So these areas, and I would call it machine vision is deep learning. So later slides, I would like to explain it more about it. So that is, so now I would like to quote one from books from uh, Michels. So the basically say if in only the robotics context, what is the machine vision in robotics? Otherwise, it will be very huge and very broad definitions. So the basically, I will quote as it is, the task of robot vision is to recognize the geometry of the robot workspace from a digital image. It is our aim to find the relation between the coordinates of a point in the two-dimensional image and the coordinates of the points in the real three-dimensional robot environment. So you don't have to worry if some people are new. What is three-dimensional? What is two-dimensional? I would like to have some slides and some detail about it, some introduction about this. Okay. So next, we will see what are the major uses of vision system in robotics. So when we have a robot system, when in industry we have a robot, or in all those factories have a robot, or there are warehouse has the robot, right? So we can do different things. There will be like in general, there are many applications. Right now I was telling here major uses of vision system in robotics. So like finding out irregularities, the damages, the flaw inspection. So the similar manner, if the task is given to human, if somebody is painting our car, by seeing our eye, we can say there is a dent or if the paint is not done correctly, right? How we do that? We don't know, right? We cannot explain it, but we do it. Our brain see by via the eyes and it can tell you whether it is correct or it is not correct. The similar manner, now if you would like to automate this process using the robot or using this computer or some application, how are we going to do that? So their vision system comes into the picture. Different applications like counting and sortage inspection. So we can count the number of objects, like we are in India, like you guys, we use Amazon, Flipkarts, or in all over world we use Amazon. So if they have to send some objects like that 5 or 10 objects has been ordered, so they also have to count it. Or there are sortage inspection, how we can automate things. And then the third one is basically like position measurement. So now if robot has to pick something and drop, pick and place application or some, so now robot has to know where the object is, in what reference, how much they have, robot has to run to reach to that object, how to grab it. So this basically major uses. Now I would call it why we should use a vision system. Now again, in general, in robotics context or in general, why we should use it, right? We can do with different application, or what is the motivation behind it. So imagine the motivation again comes. So now we have to go to the Mars, or now there is no oxygen, right? So now we can send the robot there, but robot has to see, robot has to understand things, so their vision comes into the picture. Now we have intelligence, human are very intelligent species, but we also have our own limitations, right? We somebody have maybe the height fear, or somewhere there is a fire and there is a hazard. So now we don't want to we don't want to go in those dangerous situations. So in that case also we can take utilization of these machines or the robot. Now there are very repetitive tasks. So even with the human has his intelligence, but with many repetitive tasks, we can do those human errors, right? In general, we just call it human error. That can be reduced if this task has been given to robot or some machine, because they do not think much. They just programmed for doing something and they can repeat the same thing. Now, the similar manner for increased throughput. This is maybe in some context to the factories or warehouse or somewhere. So again, same thing. We are human. We have our intelligence, but we have our limitations. We have to get good sleep. We have to take a break, right? We have to eat. We have to take bathroom breaks. We have to take, we are emotional as well. Like people are emotional as well. They are angry, they are happy, and they need, so they cannot work continuously. But if they have to produce a lot of products for the world or some, so they need a lot of automation, and then they can involve the machine in that case, and they can increase their throughput. Now, similar manner is the improved product quality because we're doing repetitive task and set to one task. So definitely we'll have good product qualities. Now, I'll talk about vision system application in general. Though our topics, I would like to focus more on the vision system in robotics. Now there are in general application. So I would not go very much detail about each topic. I'll just give brief of each of this topic so that if some of you are interested in the future, you can take this as a career option. You can learn more about it. You can go into the research. You can go for your higher studies or you can have your college projects, your experiments. So these are the different in general applications you can use a vision system. So now like everyone of you knows vision, face recognition, object recognition, we have video surveillance, robotics and remote sensing areas. Similarly in the autonomous driving. So now I would like to say now we also happen. We are in a third year or final year. I was a student like once upon a time I was a student as well, right? So everybody. So now we can say we learn programming, we learn C, we learn C++, Java or all these kind of language and we say we have a skill and now I will have job forever. So one thing. So one of the motivational things I would like to talk here. So there's nothing is permanent. Things are changing even in our computer industry or research industry, things are changing. So one good joke I found it. So I would like to share with all of you. So if you say like I have these skills and I have my permanent job for all the time and suddenly something happen and then you will be surprised. So one joke I found I would like to share with you guys. So that joke is the similarly like I don't have to explain much I guess here. So we say with my programming skills I will always have a job. And then suddenly the breaking news comes, the machine learning researchers they managed to get artificial intelligence to write the code. Then what? Then what about those programmers, right? Whatever their skills. So why? So change according to the time, like you find your interest, what you like, what you would like to do, and then just follow your passion, your whatever the good at it. So now we would also, that being like one of the funny slide I found in that machine learning and computer vision area. So I would like to just share. So now further, I would like to talk what are those vision system applications. So even like we are engineer, many of us engineer, many like work in industry. So you know we like numbers. So why like what is the revenue? What are the benefits of using this computer vision or in this industry? So these days this we have taken by this Tactica, this is the source, and they have predicted by 2022 there's a prediction model and there are different segment. The computer vision is popular these days. So the different segments. So like automotive industry, sports and entertainment industry. There is a consumer industry, the robotics, machine vision, medical industry. Then there is security and surveillance. There are retail industry. There is agriculture. And if you see this graph, so basically this automotive industry and robotics industry are into the top notch. So they are covering most of the area and also security and surveillance also some places and the consumer market. So if you see this surveillance and the security also is one of the hot topic or along with that automated car. So this is a good industry if you are also wanted to choose as your career or you want to be researchers or want to be develop or you want to do anything your innovation or any startups. So you can see different areas. You guys should try to solve the problems that helps millions of people that could reach to many people. Like just the normal thing like you wanted to make a better world. Those phrases. Now. So I would say that as I told in general application, we will just go brief about it. I'll not go any detail because we have to go for the vision into the robotics area. So but these are like just in general introduction about different topic. So right now we have face recognition. So like everybody we know like even we have iPhone or different camera like mobile these days, they has the face recognition feature. You can unlock or you can unlock your phone using your face recognition feature. So like how it happen in background. right? There are a lot of algorithms and a lot of things. This like image processing, there is a face recognition. There are different methods. So they can do by geometry based methods or templates. They use those support vector machines, principal component analysis. And the researchers, they also, some methods are holistic, like the piecemeal. So they wanted to use the features, features, we can say like our eyes, our nose, like eyes features, the distance between eyes and nose, and the different features. Based on that also, they can take a decision whether this guy is this particular face or not. Like, and then similarly, different methods are appearance based, model based, and then we have a templates or neural network based. So now neural network based is actually more popular. It's give more accurate. So one of the example here I would like to show with this image. So now if you see, we have some input frame. So how things happen, like using computer vision. Later I'm going to talk you about, as I'm again telling, computer vision is actually deep learning, or it's like, so this can be done by machine learning algorithms. This can also be done by the deep learning algorithms. So here basically we have a face database. We have a lot of face gallery with us, and then there's some mathematician or somebody, we decided some on some features, suppose like histogram features or some features. Like if you guys do Google search, there is a Google image find out, then there also you can find out, there is a the face match. So we have an input frame, and that input frame, we can find out the first, we have to find out where is the face, right? And then once we find out the face, using that like some face registration, we can compute some feature extractions, some mathematicals out of that face. We will find out some mathematical values, some model values, and then we will compare this with, we have a database of different feature extractions. So now this could be one of the classifier. The classifier will match it. It's more like a pattern matching. You have those feature extraction, then feature comparison, and then you would have your results, how much close you are to your result. In other manner, the another application is object recognition, and this is very important. And I would say this has a lot of applications as well. Like, so object recognition algorithm. So it's basically one of the computer vision techniques. We have to identify objects in images or videos. And so we can use again deep learning or machine learning. So suppose as a human being, if we have given a task, there are 10 images or there are 10 types of cats and there are 20 types of dogs, we can still differentiate which is cat and which is dog. How we do it? We don't know. How we do it? It's just we learn from childhood. Our brain has that knowledge, and that utilizing that knowledge, and we can take a decision. Now if the similar task is given to the computer or to some robot, how it will do that? So similar, that motivations comes, it will use those computer vision and then deep learning knowledge, and then it will take some decision using algorithms. So this object recognition, now different application. This is a key technology, I would say. Later I have some slides for driverless cars or those autonomous vehicles. So there also it is a very important technology, right? It enables to car to see the stop signals to all these, it can identify where is the pedestrian or where to stop, like when to increase, when to decrease, and where is the turn, like so much. So it's very important. We have to recognize things, and in different applications also this object recognition techniques are getting used, like we used in industrial inspection or in bioimaging. And now we can use, as I told, deep learning and machine learning. So we're gonna see further. So if one of the image here I would like to show, suppose what happened. This example will be more similar to that cat and dogs. So now we have car, trucks, or bicycle. So our task is we have a different images. Now among those images, we have to tag them. What are the car? What are the trucks? What are the bicycle? Now, similarly, we have our and now we can also see what is the difference between machine learning and the deep learning here. So if some of you might already know, there's a term called like supervised and unsupervised. So supervised means they have a lot of we have to do by ourselves. We have to extract the features, we have to train our system, and then when unknown things come for the similar unknown things, we have to again compute a feature and that compute that new feature with the existing trained features and then take a decision out of it. Now with the deep learning, it is more about, I have another slides for this one. So there we have a different models, like one is a convolutional neural network, CNN it's called, and then we have a different layers. So using those vision, you will have your trainings, you also have different layers, and then you can take a same decision, but will maybe it's a good quality result. Now, if you say in another term, so in machine learning in the section A, and then the B is the deep learning. Section A, even with our human help, we have our feature engineering. Manually, we can compute a feature, like we just took a picture, then we compute some feature, we store that feature in our database. Now some unknown things come. For that unknown things, again, we compute this feature in similar manner. Now that one feature we compute with our existing training, and then we decide what label it is, or we can classify that. That's the output. So that is basically the machine learning here. Now things happen a little bit different in deep learning. So deep learning, we can also involve the training, but there are not just one training. It can have a layers of training. It can also utilize the pre-trained data. So you can see in this image, there is a feature learning plus classifier, and then another term called reinforced learning. It can also learn from its own results, or like it's same like a human, right? The deep learning and all these neurons, these are motivation from the human. So now, basically, again, as I talked about it, this model such as those CNN, we are using for inherent features. Now, basically, two types of approaches we can use here. One, we can train a model from the scratch. Basically, I was telling about those machine learning, or and you can decide when to use what. So training a model from scratch, if you are having some application that is limited to 10 objects or 20 objects or 100 objects, so you can only train to that 10 objects, 100 objects, and then you can identify two similar objects in your factory. Like if your factory is only about apple and banana, that's it. So you just train apple and banana and no other objects would come into the picture. But if you have a broad object recognition applications, we can also utilize, we call pre-trained deep learning models that I was talking about. So there are different models into the market. There is a Google Net, there is a RESTnet, there is AlexNet. So there they already trained their model with millions of images. There are millions of data is there. And now top of that training, we can add our own training. We can train it again. And so this if you any of you guys are interested, you can go further read about these models. You can go for this deep learning analysis, and then so similar manner. Suppose another example. So I was talking about deep learning can utilize for object recognition. So deep learning. So if we have given a task and it's give you, is this a French fries or is this a sushi? So we have a prediction. We have given some picture and the deep learning model is predicting into the restaurant food. OK, this is a French fries, and this computer is 100% confident. But for the sushi, it says, yeah, I would predict this is a sushi, but my confidence level is 97%. And there is also another research. You can also sometimes you can fool the computer because something that is looks like this computer can also predict. So there are error case. Now, so the object recognition we did with the deep learning. Object recognition you can also do with the machine learning. Why I was covering this area, because they are very important, and as I told in computer vision, object recognition is very important techniques. So now, as I told, if we do not need that much computing, if we do not need that much broad applications, we can also use our conventional machine learning algorithms. So there we can use like, different feature based. So object recognition. So there are different features, like one is you can again learn more about these features. The hog feature extraction, SVM machine learning models, the bag of word, the surf, and using these things or different algorithms, we can do object recognition. and they are less computing. So again, when we have a not like maybe the limited resource, not very good computer, not with very good hardware, limited resource, we can choose to use this using machine learning. So the same time, deep learning is good. It gives you good results, but it's also resource hungry. You might have to train for millions, images and then computing power. Now another applications I'll talk about, that's video surveillance and monitoring. I know many of you guys are scared or seeing like, but yeah, this is one of the applications. So at same time it is good or bad. So this machine vision or computer vision is also enabling system to surveillance. So now if any of you, like even in India now, we have in New Delhi or Bangalore, you would see a lot of CCTV cameras. Here in United States also we see a lot of cameras, and I heard and I have different like news, Baidu, or in China they also use this lot of traffic signals to do surveillance and monitoring. Well, this lot of controversial topics, I would not like to go into that, but I'm saying it can go beyond, right? Like, so video surveillance and monitoring area. So basically in general workflow, if you see for the video surveillance, so so using those computer vision technology, what you can do, you can identify the object, you can recognize, you can detect if some person John is missing or some person John is trying to hide. Using those those traffic signal cameras and all, government can find it. They can maybe look into, okay, first they identify this is John. Now they can also track the John. That's just an example I have taken. Like if somebody name is John, please don't be like. So it's just person X, we can also track it, object tracking. So wherever person X is going, we can track it. Then we can also categorize, and this is the person, we can also categorize within objects, like we say dog, cats, or different labelings. Then using this surveillance techniques or those machine vision technologies, you can also find out if it's the event or activities. Like suppose people are protesting, right? People are their angry faces, so they can understand there is some kind of protest or people are angry, or people are circling around, or people are running, or they can judge or they can guess the mood of the people. So there at the same time there are a lot of things they can be done, events or activities, they can find out what is happening. Okay, so well, so I'll go to the next very interesting topic. So I also like this, one of my favorite topics in the computer vision. So autonomous driving. So maybe many of you also would like to imagine maybe having a like autonomous car or some like, though it's again it's not a norm yet, but I don't know, never say never. Like it can come maybe in 10 years, 20 years, who knows? Like we already have here in San Francisco, right? Some label. So these are very hot topics in this computer vision industry. So basically I would like to give you guys one demo here. So here in California, Tesla is very famous, you would have seen it. So just a second. So there is a no audio in this actually in this video. So you would not see the audio, but you see, so the using this computer vision, how this car is enabled. And if you see, human are still behind, but it's not holding hand. And then the car is able to identify where is the stop signal when it has to take a turn. A lot of cars, and there are car driven by the human, and there is autonomous car. And it's taking it right lane, and sometimes it has to change a lane, and then it will go also, right? You see somewhere stop signals, it will go exit, end, and if it's a green light, it will go continuously. You can try to figure it out. So I would like to share my own personal experience. Like I've been with the Tesla, and it's very cool. Sometimes it is scary, but it's very cool. And it's also completely not permissible. Like you have to still behind the wheel, like you don't have to hold the wheel, but you have to be on the seat. So if anything happens, you can take control. So they allow you, but they are pioneer. They are very much ahead right now. So there are different companies are working on this self-driving car demo. So maybe I think you would have got some idea. I can go for the next section. So you see there is stop signals, they stop it. So now what enables, so if we talk about what enables this autonomous car, what enables, how they see it, and there is a link. So now, if you say now autonomous car technology, right? But how this car can see, like what empower them to do this? So they have a lot of, again, cameras, they have a lot of sensors. So now what these sensors and what these cameras do? So these cameras empower the car to read about where is the traffic lights, where is the signal, and there are different, there are ultrasonics, there are LiDAR, there are laser-based LiDAR technology. They can see beyond 200 meters. So they have a lot of these sensors. And now using these sensors, we also have to process this data very fast. Imagine if you take a decision late, you are about to hit like some objects, but the process is delayed, so you were already met to accident. So that's why it's very critical. The same time, the accuracy and then your computation power. That's why there are a lot of technologies and still a lot of research is going on. So now with again those paired with those AI in computer vision. And right now we are also using in India also have a lot of, I guess, these facilities nowadays. In United States also we have these. So we also get this autonomous feature in partial manner. So partial manner, what they enable us, the automatically they give us lane side lane detection, lane boundaries. If somebody is a sleepy driver or somebody drunk or drive or something, the car will assist you like you are not driving straight. They're gonna give you a response back. The car is now helping you to find a blind detection, or you're changing the lane, or if there is also collision prevention options are given. It is not guaranteed, but when the car sense it is about to collide, they will have automatic brake. There are a lot of features coming, but they're coming into the part. So now, like one of the I have taken from one source called AI INC. So their AI INC, this car basically has this. They are also working on those LiDAR technologies, and they would say, yeah, fully autonomous car aren't the norm yet, but these companies are all are bringing. They are working very much into this area now. I guess different companies, the Uber. Now people start to use Uber, right? Uber also working on those automated car, like Lyft also working. Many companies in San Francisco are working in this automated car. So again, this last one in the automated car section. So we would see what are different components, right? So this in the car, you would see this LiDAR units. So on the top, like they are also actually the costly sensor. There are different cameras and they camera see in 2D and 3D. There are a lot of point cloud computation and different later section I'm going to talk about. There are radar sensors, there are additional LiDAR units, and then the back they can have the main computer in trunk. So every data has to go to some computing process, and then it's more like a brain, like we are seeing and taking inputs from different sensors, and then like a brain software, like a main computer, it has to process this data. Now we'll go back to the, again, that was the general applications. Now we would see vision in robotics. So like in general, vision in robotics, like what are applications? If you just focus to the robotics area. Now, like if you use it, so error proof. So again, if the task is given by the human, there are human errors, there are chances like welding error or something or painting error and all. But if you do these tasks with the robot, there are less chances of the error. Then again, a robot has to pick and place something. So using the vision, we can have this location and orientation. So when coupled with 2D or 3D sensors, the robot can made to perform very different complex tasks. Like suppose I was talking about, I would have some video, I guess, for this our company robot. Like some applications like pick and place, the robot has to pick something from the bin and then place. And then into the warehouses or factories, there are conveyor belt, and like Amazon warehouses or anywhere, like you can name it, different applications. So now in the robot section, so let me see if I have enabled the just a second. You guys should see, I guess, the audio. So now this is the robot bin picking application. This has the sound as well. So you should see the sound. It's basically ABB robot. All right, basically the idea, maybe this much would have given some idea. So we would also have to like cover different. So here I would like to say, so if you can see in the videos, the robot is trying to pick up, it's a reverse bin picking basically, and we are loading the bin. We are loading the bin, we are taking. So what empower these robots? So you would see some camera on the top that is taking a picture. There will be a flash in between. So someone has to see it, right? Then only it could be enabled. So now we go to the next section. Now different application now in a remote sensing. You would have seen these days we have a lot of drones into the picture in US also, in China, or every country these days. And the computer vision also can be used in the remote sensing applications, right? And also maybe in the satellites data are coming, or we are going to the Mars or going to the moon, and we have to like process so many pictures like high, so that the vision also would be helpful there. So again, I would not go more detail into this, but like conventional technology was not that enough or giving the good results, but using a computer vision or deep learning, we can have a more robust and accurate results. So I'll go to the different section. So now, if you guys would like to have a career or would like to have a more interest into the computer vision or vision in robotics, so you would like to have you would have to know the basic things about the vision. So what enables it? So basically the image. So the basic elements of the computer vision or the machine vision, these are the image. So what are the image, right? We say image tells everything. So without saying a word, we can see things, we can guess things from the image. So image is nothing but is just a 2D array of numbers, and these numbers represent their intensities, values, their gray labels. So now we say 0 is the black and 255 is the white. So they vary from 0 to 255, and in between they will create different colors. So now the color image is basically the three two-dimensional array. So each two-dimensional array, one is for red, another for green, and RGB basically. So the red, green, and blue, the combination of these three channels, we make a color image. Now, what is resolution in image? So if you say number of rows and number of columns, these are called the resolutions. So we say now this much megapixels in the picture, right, is the camera. So basically that's the resolution. So right now we have 640 by 480. We can have also 1280 or something. Previously it was less resolution. These days now images are coming with high resolutions. Now The another good thing I want to talk about when I was passionate about, if I talk to, like, I was working in a Bangalore, as a software engineer, and then I was passionate, or to go to the research, and I came from a master's, and then I went to machine vision lab. So then the first thing, it's passionate me, how things happen and where this stereo vision concept comes, why I was relating that story to here. So I had this, lesson in my class. So I would like to share with you guys. So basically, the human, we have a two eyes, right? And these two eyes is basically is a three dimension, and they call it like uh, it's a human vision is actually very complex. We just say it's a simple, but we say like stereo vision, stereoscopic vision, or stereo. So what happened if you see in this picture? So in the behind we have a brain, and thanks to God we have our eyes side by side, not like a horse. Like horse is the very on the side. So if you can even do one exercise, so if you guys are seeing this image, our each eyes take a picture differently. Our left eyes see most of the left portion of the object. Suppose if you guys go to the bowling and all, so if you see the left eye is taking most of the left side of the picture. If you close, if you can do even one exercise, you can have a, cover your right eye and see your finger or some object in front of you. Then you would see a different image, like seeing from the one eye. Then after this, you cover your left eye and then you see same thing with your right eyes. So you would see the object in like the different views. So now what happens? So these two different views taken by these two different eye, left and right. Now both image separately sent to our brain. Like our brain in the back, there is some processing units that will process these both images. It will combine their differences and it will make one image. By making that one image, the brain will guess it, right? How much is the width or orientation of these objects? By this, if you have to grab some glass or some cup, how much your finger has to go, like otherwise you see things in 2D, you can guess someone is very thin or someone is having like dimension also you can guess it. So this is very fascinating, and this is the motivation for the computer vision. This is the motivation for the cameras. All these camera technologies are basically based on our human eyes. So later I have another slides for this. This is this exercise you can see. You can go to this link and they have another funny games also, and very good games. Now, so by seeing this, are you guys sure you have got a stereo vision? I think every one of us got it sometime, knowingly, unknowingly, we don't know. But you can see some people are very good at it, seeing, those 3D movies or, something, and some people have less, but you can do this exercise and you would find out. So we have stereo vision. Now, so I would go to the different topics called image formation and computer vision. So what are important factors for the image formation? So there is one is light. Light is very much important here. So light intensity, there are, what is the label? We can also have a unit for the light. So the light, and then here I'm assuming because I'm mostly talking about 3D vision. So here like a 3D stereo camera. So there is like extrinsic or intrinsic parameters. You don't have to worry right now because they might be the new word for you guys. I'm going to talk a little bit about it. So basically image formation happen using these two information, light source and their intrinsic information. Now, if we say the intrinsic basically means is internal to camera. So now we happen, right, camera can have an error. So it's basically we have the values for, camera focal length and their principal points, and they can have some errors. So some examples, we can place one objects in 10 different places and take pictures from the same camera, and then we can find out where is the gap, where is the accuracy problem. So these are the intrinsic parameters that give their how much offset we have to give for getting a good result. Now the second parameter called extrinsics. Now as by the name, extrinsic means external, from outer world. So in the later slide I'm going to talk about, it's called the coordinate system. So basically the extrinsics are into helpful in the world coordinates. So if you are like we all are somebody are sitting in a room, right? So you can see in your room you can have the width, your width, height, and your length. So like if you divide things in X, Y, Z, your wall, you can imagine, like, we have a 3 dimension, so things. So now similarly, so we have something into camera coordinates. You don't have to worry about, again, I'm gonna give maybe some examples, and then how this thing will happen in the world coordinate or some robot coordinate system. So for that information, we need this extrinsic parameter. They are basically represented by uh, 4 by 4 matrix. Among that, we have a 3 by 3 rotation matrix. And rotation and translation, again, I'm going to talk about. Translation basically means their position in XYZ, and then rotation means what is their angle or their orientation and all. So now if you see another information in the robotics, so we follow here basically right hand rule. So if each one of you guys are seeing maybe the presentation, you can have this little exercise. If you have your right hand, you can just have your hand like in an image. So if your thumb basically is pointing to the upside, and that basically actually z axis, that's a cross b of the two vectors. If we say a and b is a vector, so the z basically is the multiplication of those two vectors. And your first finger is pointing to generally x direction, we call it vector term is a, and then your second finger or palm basically into that y direction, that is basically the b in the vector terminology. So we follow in this robotics until unless it is told by default, we follow right hand system. All these researchers, this is more like a right hand rule, 3 Cartesian coordinates. In the left hand, it will be like different. So now this is kind of a coordinate transformation robotics. So robotics, as I told, by default, we have our right-handed coordinates. Now coordinate transformation in robotics continue. So how we can represent these coordinates? So now, as you have seen in the previous slides, I was talking about translation and rotation. So basically, if some point like into some world coordinate or robot coordinate system, that point can be represented by x, y, z. So that is actually specified by position, and that we call it translation. So now robot has to move how much from its base position to reach to that object. So suppose it has to reach this much in x direction, this much in y direction, this much in z direction to reach and just pinpoint to that object. Now the orientation basically is the rotation. So object can be on that particular point, but it could be tilted, right? It could have some angle, 90 degrees, 45 degrees. So this is basically the rotation. So it's very fascinating if you have to hold something, how if you have to hold something by our hand, cup, right? You have to tilt your hand, or how much you have to reach. Your eyes giving this information to the brain. This object is this much far, and you have to reach this much, and you know the distance with reference to your body. Where is your hand and how much your hand has to move. This similar manner happen in robot. It's very much the same thing. So now the different representation of these values, you can again read more about these. There are axis angle, Euler angles, homogeneous transformation matrix, quaternions, rotation matrix, translation vectors. These are more if you would like to understand more. Now, if you say, I'll go to the different topics because there's like 2D machine vision. So now the vision can be divided again in 2D machine vision and 3D machine vision. So now what is 2D? So again in two-dimensional, basically X and Y. So like in mathematics we have generally, right? So if you see the basic example here, the funny part, if many of you guys would have been into the plane, right? If you go in aeroplane and if you too much height from the top, you see what are you able to figure it out any tower or something? Mostly we see things in a flat, right? So everything is a flat. So the representing things in a flat, and we have basically represent things in X and Y. So this is also could be advantages and disadvantages of the 2D things. So basically giving those flat information, this X and Y, this 2D machine vision we can use in inspection task. We can also have here detection and all, but it has its own limitations. So now, so what is the applications? So 2D vision, 2D visions can be again used into that inspection task. If you have to find out, suppose this some paint is done or not, or some other information, their basic, their depth is not required, right? the node, because it doesn't have any Z information, the no depth of the field. So, but sometimes again it's challenging because we have a lack of third dimension. So for the complex task, it will not give you good results like a bin picking. So now, so I will tell you that another like very motivational. So now using those 2D and 3D vision, so you guys would see maybe this. So Amazon will come up with this autonomous robot. So they have this pilot test in Seattle, and so now they have a packaging industry. All right, so you guys would have seen, right? So the Amazon is using those 3D vision technology for delivering their packages. And I don't know, like again, I'm saying this is not very far, maybe 10 or 20 years, packages could be delivered by drones or this. So they are in experimentation mode right now. Now we go to the 3D machine vision. So this is the very much is a current trend. So a lot of application using the 3D machine vision. So although machine guided vision, like it can involve 2D sensors, but as I said, they have their own limitations. We use mostly 3D vision system, and we have because using those 6-axis robot. So the previous video I showed you, there also we have those 6-axis robot. You can more Google about it. They can have a 6 degree of freedom to moving. So now like our hand also have like freedom, right? So similar, like our hand have I guess 3 or 4 degree of freedom. So now there are several 3D sensor technologies to choose from. So we have a laser displacement, we have a structural light, we have a point cloud. And this point clouds and all, I'll tell you, maybe if some of you students and you would like to learn, there are some open source tools and libraries that is very useful for doing experiments and learning in 3D vision. So now again, same thing. So we have seen that stereo examples, right? Stereo visions. So similarly, these cameras having the similar motivation to the eyes. Generally, those 3D cameras or stereo cameras have this two sensors. Generally, their left side sensor, right side sensors, and they put a light on it and then reverse. They take two images and then they combine that one image, and basically so and they represent that one point into that three-dimensional coordinates that we call it X, Y, Z. And then 3D camera generates the point cloud, right? So one of that point cloud is basically again is a collection of points in 3D, X, Y, Z. Then image processing software analyze and we can guide it. So there are different applications. So even those autonomous car, they use this 3D vision technology. So now, as I said again, 2D vision has its own limitations. With 3D sensor technologies, we can do more complex tasks. There we need more depth information like pick and place, that bin picking. The previous video I showed you with ABB, they were using 3D machine vision technology. So again, with the 3D vision system, we can have a different type of setup. So now like we have an eye fixed in our, we have two eyes and one head. Like now robot has the option, either these robot eye or this robot vision sensors can be attached to the robot hand, or it can also be a little bit further. So either we can attach into the end of the arm of the robot, or we can mount the camera maybe above the robot, but then it's have its own limitations by the height. Some the cameras have their range, right? If you have to be this much meter or within the range, but they mounted above the above the robot and then lane pointing to downward at the robot workplace. So this two-way we can have it. So now different applications we can use because those 3D systems give you more, rich data. We have different applications, right? Like we can have shape there, we can have orientations, we have a bin picking, and then if we can properly use these 3D vision technologies, then we can avoid a lot of errors because we have a accurate their location, their accurate orientation and accurate presentation in our world coordinates. Now, they're basically the application, the video I showed you, this basically that bin picking, a lot of applications that in industrial robotics segments, a lot of like bin picking, we have those warehouse automation, there is a conveyor belt and we have to pick object from the conveyor and we have to place in some objects. Then we have another benefits of 3D vision. We can also have those object detection. We can match the part. We have some existing registered maybe CAD model. If you guys are mechanical or somewhere like using those MATLAB, or you can create a mesh or CAD models. So use these existing registered 3D CAD models. We can also get unknown objects we can compare with existing 3D CAD models. So that's this also empower us for this 3D CAD model comparison. Now, for the like as I told, those who are the beginners or would like to have a career in computer vision or these tools or wanted to do your college projects or your thesis, you can like you are welcome, or you can so it's different very important tool about those computer visions. So this one like maybe it will be not complete without talking about these tools. So like OpenCV, so this like open computer vision. So I have also given here link. So this opencv.org. So a lot of these computer researchers, we use this heavily. So like I'll not talk about more about my project. Some of the projects we do in just proof of concept or confidential IP label, but I can just say about technologies. So yeah, we also use this OpenCV things. Lot of OpenCV uses, and it's also in different language. You can use in C++. You can use in Python. So I guess they have a different version. So another one is like a MATLAB. So if you do your master's, your PhD or whatever, so it's very much you can have a lot of simulations, a lot of mathematical, your matrix computation, your lot of things you can be we can be achieve by using these in MATLAB. Another these computer vision tools and libraries I would maybe some of you already know is popular these days like a TensorFlow. They are basically like a Google big pioneer in technologies. There was internally they developed it. I guess 2015 they did it open source. They make it they make it available for all over the world. So and then TensorFlow is growing from them. It's mostly in a C++. It can also be like sometimes resource hungry, but they also have its advantages and disadvantages. But it's a lot of examples, lot of libraries, and lot of pre-trained model. So if you would like to do any experiment, or even also you can include I guess your Python applications. You can make your basic examples of computer vision, object detection, or recognitions, or you have your toy robot, or you want to play. You can do a lot of things. Then other tools called CUDA. So CUDA is actually basically is open source softwares developed for those you have those parallel computations. So it will make your computation very fast. It will basically utilize your graphical memory, right? How much your graphical memory. If some of you guys are definitely you guys are playing maybe video games and all, right? So if you play video games, you would have those, you would know about those graphical memory and all. So CUDA is basically utilize those, and that it enables to do those parallel computations. So it developed by the NVIDIA. There is another called Simple CV. It's basically more like OpenCV, but it's very simple and lightweight. Again, you can utilize and do it a lot of. And now then I guess we are almost close to the our end to the presentation. So I would also talk now this industry is growing. So now this is very popular in computer vision also making as a service. So now these days now Google Cloud and mobile vision APIs again because it's require a lot of resource, lot of applications. So now Google also giving them as a as a service. Now similarly is a Amazon recognition. They say recognition. So they're also giving using these services. You can have your lot of images. You can have your identification recognition, your labeling. Then another is from the Microsoft Azure, the computer vision API is the same thing. So these all companies they are also helping to communities. maybe using their cloud technologies. Amazon have AWS, the Google Clouds, and Amazon, Microsoft Azure. So they are. So if you guys, these are a very good resource. If you would like to do experiment, you would like to learn, and I would like to say, you find your passion where you would like to grow, what you would like to learn, like, and then you decide on this. Now, basically, now last topic, I guess here. So if basically where the robotics vision research problems, these open problems where this going on, robotics vision basically now humanoid robot, like robot should do basically like a humans until it see and think, then redundant arm and hands. Then we have vision based robot localization and navigation, computational models of human walking. So like how human walks, so we have to find out and learn it, like because we are a lot of adaptive as well, we can run. And then there is a differential system, and there are a lot. So these are different applications, right? And again, I would say we should have, passion about things you would like to, what you would like to learn, what you would like to know. And if you try to solve something, some problems, say we say invention, like necessity is the mother of invention. So there are a lot of problems they are unsolved. So you pick up one problem, if you try to solve and that is getting used by many people, then like you can make a better world, something like that. So the one famous quote, I would say, I would end my presentation with this, like Steve Jobs quote: stay hungry, stay foolish. So, all right, thank you. And there is my LinkedIn link here. So if you'd like to use, if you'd like to contact me or have more information, you can contact me in LinkedIn or some social media. All right, thank you guys.
Thank you so much, sir. Thank you for sharing your deep knowledge with us. The session was really insightful and enlightening. We will go ahead and take some questions now. So just a reminder to be sure, to all the participants, just make sure you are typing your questions in Q&A, and we are going to answer those questions. Sir is going to answer those questions. So it looks we have few questions here. So sir, I'm reading the questions one by one, and you can answer. So Mohit is asking, what is the difference between machine vision, computer vision, and robotics vision? Is all are the same?
It would be like, good question. I would say it's moreover like they all are same. So we just call it robotics vision, means more focused on the robot. So we are giving into the robot perspective, because robot has its own, limitations, or a robot has its own coordinate system. But when we and then the pretty much it's become like a sensor for the robot. But when we say the computer vision also can be used without the robot. So they say like machine vision in robotics. So but in other terms, again, I would say one term, machine vision or computer vision is deep learning. So even in automated car, we use it. So they are almost also same. Yeah, in my term.
Okay, thank you, sir. Arnold is asking, I had underwent training on KUKA robotics, industrial robotics back in 2018. Machine vision wasn't much implemented. It was in the research phase. My question for you is, in industrial robot, is the machine vision used only as the end effector, camera fix at the end effector of the robot, or is it implemented to the entire workspace of the robot? If the machine vision is implemented to the workspace of the robot, then is it only to detect human entering the workspace? When industrial robots, one minute, when industrial robots are in action or in any other main purpose of the same?
Okay, so let me try to give maybe a little bit detail about it. So well, I know KUKA Robotics. So basically, they are one of our competitor. So if you go in industrial robotics segment, so there are two or three only leading companies. So like ABB Robotics and our companies, and then this KUKA Robotics. So yes, I would say still this computer vision, this is still a child. Still it is growing. It is still not matured enough. Like automated car is not yet the norm. So similarly, we are having machine vision applications, but they still not that much mature, I would call it. So but right now again there is a focus applications, so we have some application, maybe Kuka Robotics or some of the projects we are also working on, or they are also working on, but like I cannot share so much detail about it. But in general there are there are application in industrial robotics. Now robot has to do some warehouse automation, so they would be used basically in this section. And I guess they are now popular, more popular in these bin picking applications, like we have to in warehouse and replacing those humans for doing those packing and barcode readers and pick and place or depalletizations. So but some company I guess started using it, but still it's in a like growing phase. Okay, I
Okay.
hope you would have answered you a little bit.
Shubhadeep is asking, if the road condition is bad like Indian road, which sensor sense those?
Yeah. So I also grew up in India, right? So I've been there, like I have seen the even Bangalore traffics. I used to work there. And yeah, these are there are some of the challenges. So again, so that's what I said. It's not a norm yet. So it's happened like it's a road is bad condition. Similarly, what about like the camera is seeing the lane of the the road, right? We have like a white strip or something. But what about when the road is bad or there is a heavy rain or there is a snow? In United States, there are a lot of snow in some areas, so road is completely covered. So now this only seeing by the camera or just having those color images or point cloud would not be enough. So there are researchers working on different technologies like using radar or lidar technology. So they don't have to depend just by seeing by having their mapped. So if they know if the total width of the road is this much, you are on the which side of the road. But again I'm saying it's difficult. It's difficult on those difficult terrain of the road. So but they are finding some solutions, so mixing, but again the lidar and using radars has become costly. So they are mixing technologies and still in a growing phase, and I'm sure these researchers are working. So one presentation like I shared, one guy from I guess from MIT, one video I showed. You guys would like to maybe visit and see their videos. They are like into that good research and different companies. I hope this will help. Yeah.
Okay, next question we have again from Arnold. According to you, what that one main thing which is making India lag behind in research in AI or machine vision when compared to the foreign countries like US? Is it because the unavailability of the resources or any other reason apart from this?
So this will be more like a political question. I would say everyone, there is no right and wrong, and everyone can have their own, uh, thoughts about it. Maybe in my thought, I'll give just my opinion, and again, it could be wrong, and I might be wrong. I guess it's more about the market and maybe the investment, maybe the government or the interest. So now here, like there are a lot of environment and people wanted to like also use those technologies, and also their infrastructure is good. India, it has its own challenges, I believe. So we still have the different, but we still growing. We have still, and we are adaptive. Like we change things very fast. So there is a positive, and the things gonna change. But I guess it is slow. If you directly compare US technologies with the India technologies, I guess it won't be a fair comparison. In like in a different context. So yeah, the both are growing. India also growing, but maybe in a slow phase. Yeah.
Okay. So another question we have, are sensor designed for all trains or depending on the place each sensor is made? If so, how is it compatible?
Can you repeat like this one? What they're talking about?
Sure, sir. Here is the question. Are sensor designed for all, I think I'm not pronouncing it properly, terrains, or
No.
depending on the place each sensor is made? So if so, how it is compatible? Um, so you can see all the question here. You can on your screen there is a question mark, Q&A.
Okay, okay. Yeah, yeah.
If you will click, you can read all the questions.
So for my end, the question that someone is asked, my end, I would say as a researcher, so there is a no one thing that is perfect in all the condition. So it's, you know, it's always using, different. So like no one is perfect. So similarly, sorry. So similarly, one sensor is not perfect. So as I told you, like as my limited knowledge about those autonomous car, so this one, they are not using this one sensor. So if you are in different terrain, definitely they have to use the different types of sensors. Some sensors are good in some terrain, some another sensor are good in different terrains. So like there are a lot of slippery roads, so there is no visibility, or so they can use by different technologies. And their resolutions might be different or their range might be different. So they are trying, but there is no universal thing, but they are trying to achieve it. But I believe they might be utilizing a different sensors and combination of different technologies.
Okay. Another question we have, this is very interesting field to work. Can you share some resources from where I can start as a beginner? What are the prerequisites to understand and grow in this area?
So that's a very good question. I would say those who are the beginners and definitely would like to learn. And I would tell you about even my story. So I was a software engineer. I was good at like maybe data structures, algorithms, but I was very beginner. But I had a passion about it. I would like to learn this machine vision or machine learning. So I came for masters and definitely having this background in data structures, algorithm, it helps. So but you can start from anything, from anywhere. And the sources in my last slide, I guess I have shared some of those tools. So those open computer vision, OpenCV, and point cloud libraries, and using even OpenCVs, they have a lot of examples. So if you know even limited knowledge of Python, that would be enough. Or if you are good at C++, that would be also enough. And then you can start learning about those coordinate system, and then basic they have their examples. So you can start using those open source libraries. They are available in internet using the Git. You can just download and you can just run. And there are also some of the online examples or tutorials. So I think it's not that difficult. If you are passionate about it, if you wanted to learn it, you can start it.
Okay, next question from Pawan Kumar CN we have. How it raises its speed when the signal went off? I think about automatic car he's asking.
Okay, so if I understood the question correctly, he would like to ask how it will raise the speed when signal is off, or it has to go fast because signal is going to be red, something like that.
Yes, sir.
So if I would say, so it's a funny incident, right? Even in India, it's happened. Even me, like people are joke around like when it's a green signal, we just go, right? When it's a yellow and when it's a red signal, we just see nobody is watching, then we can go. But it's not like that. So I would say, so in the like it has a prediction about, right? So it's like yellow means like ready to stop. So yellow means ready to stop. So it will not increase the speed. So when I was in Tesla, what I have seen in my experience, basically when it see the yellow signals, it's tend to stop. Generally, when you have a yellow wherever you are, you try to just finish. If you are half of the signal, you just cross it. But you are before the signal, the Tesla car was stopped to the yellow, and basically that should be. And when it is red, definitely it has to stop. So I would say if all the cars is automated car in the road, there is a less chances of even collision or less chances of accident. Actually, it is good. We are the human, we do more mistakes. but the human and robot combined, it's again a trouble.
Okay. Uh, Sir, can we, it means if the time is exceeding, we can mail you all these questions and you can revert us back and we can share with the participant because so many questions we have. Uh, if you
Okay.
say the time is exceeding, I can stop here and I will mail all other questions to you.
Yeah, that would also be great. Yeah. You can
Okay.
email me and you guys can reach me for LinkedIn or yeah, if any questions or anything.
Okay, please.
Sir, can you share one more time your like social link profile link so that our participant can join from there? One more time, you can share it, sir.
Yeah.
So, dear participants, we are going to mail all the questions to Sir, and you can also join him on LinkedIn. So, you can ask or message him directly there. And as soon as Sir will revert back, he will go through all your questions and revert back. We will be sending you answers for all the questions because many questions I can see. It was obviously very interesting session. There are many questions I can see here, and because we already exceeding the time.
So I have put in the, I guess, meeting chat. You guys can see that.
Um,
Sir, I think we can't see.
1 minute, I will publish, no problem. Here,
It's
I think
meeting chat.
I'm putting in the announcement. Everybody can see that.
Okay, yeah, that would be great.
Okay. Okay, so it's look like we are covered with everything. Now I would like to request Miss Vinita Dominic, Assistant Professor, Department of CSE, to give away the vote of thanks.
Good morning to all. On behalf of IEEE Student Branch, Presidency University, I, Vinita Dominic, Assistant Professor, Department of Computer Science, would like to deliver the vote of thanks. First of all, I would like to thank Mr. Ashish K. Tiwari, Senior Software Engineer, Robotics, R&D USA, for giving such an insightful webinar for us today. Sir, we understand you have delivered the webinar from a different time zone. Thank you very much for cooperating with us and doing the same in the same available time slot. Thank you, sir. I'm sure all our faculty members, research scholars, students have really benefited from this webinar. Thank you, sir. Then I would like to thank Dr. Nizar Ahmad, Chancellor, Presidency University, Dr. Radha Padmanabhan ma'am, Vice Chancellor, Dr. Badri sir, the Registrar in charge, Dr. A.M. Surendra Kumar, Dean, SOE, Dr. Kalai Arasan sir, Associate Dean, School of Engineering, Presidency University, Dr. K.G. Mohan, Professor and Head of the Department, Computer Science and Engineering, Dr. Tivakaran, IEEE Faculty Coordinator. Then I would like to thank my colleague, Ms. Mitali ma'am, for organizing such an insightful webinar for all of us, for coordinating it with sir. Thank you, ma'am. Then last but not the least, I would like to thank Ms. Shaleen Bhatnagar, IEEE Student Branch Counselor, for organizing such an amazing webinar for all of us and for supporting it and providing a platform. Last, I would like to thank all the participants who have joined us today.
Vinita ma'am, your mic is mute. Yeah.
Yeah. I would like to thank Dr. K.G. Mohan, Professor and HOD, Computer Science and Department, Dr. T.K. Tivakaran, IEEE Faculty Coordinator, Mitali ma'am for organizing such an amazing webinar for us. Thank you, ma'am, for sharing with, for coordinating with Ashish sir and making this webinar possible. Then I would like to thank Ms. Shaleen Bhatnagar, IEEE Student Branch Counselor, for making this possible, for standing as a support to make this event such a success. Last but not the least, I would like to thank all our participants, students, faculty members, IT professionals, professors, and everyone for participating and giving your valuable time to us. Thank you once again. Thank you all.
Thank you so much, Vinita ma'am. Again,
Thank you.
thank you so much, Ashish sir, and thank you, Mitali ma'am.
Thank
Yeah,
you.
thank you, ma'am. So, ma'am,
Participants, the feedback link is shared with you. Kindly give your valuable feedback. We will be sending all the important resources to you, including the recording. So we will be mailing, or we will be sending on Telegram group. You all are there in Telegram group. We will share the details of each and every resource with you.
okay, we are ending the session now.